Show by counterexample that the statement sec squared theta is equivalent to 1 minus cosec squared theta is false. Find all the values of theta in the range of theta between 0 and 360 degrees, satisfying 3 cosec squared theta is 11 minus 2 cot theta. Let's have a look at this then. Counterexample, so what value of theta should we put in here? Should we try theta equals pi? Could try pi. Try theta is 0. Let's just try theta equals 0. Sec of 0 is 1 over cosine 0 squared. Cos 0 is 1, so that would be 1. Is equivalent to 1 minus. Cosine is 1 over sine. It's not defined. So right hand side is not defined. Whilst left hand side has the value 1. So it cannot be equivalent then. There's the counterexample there. Because when theta is 0, this right hand side is not defined, whilst the left hand side is defined and has the value 1. So that's false then. So part B. So part B now. Now in B, cosec, we want a quadratic in cot, don't we? So remember sine squared plus cos squared equals 1. If we divide by, we want 1 over sine squared, don't we? Cosec. So if we divide by sine, we'll get 1 plus cos over sine is cot squared equals cosec squared. There we are. So we can replace cosec squared then by 1 plus cot squared. So it's 1 plus cot squared we need to put in instead of cosec squared. So here 3 of 1 plus cot squared theta is equal to 11 minus 2 cot theta. Expand the bracket, 3 cot squared. Move this over to be plus 2 cot theta. We've got a 3 when we expand the bracket. Move the 11 over to minus 11. 3 minus 11 is minus 8. Now we can factorize. It's got to be 3 cot and cot, hasn't it? 4 2's it probably is, isn't it? 2 of these and 4 of these. And then if we have minus 6 plus 6 minus 4, that will give us plus 2, won't it? So we've got 3 cot squared, plus 6 minus 4 is plus 2 cot theta, and then we've got plus times a minus is a minus 4 2s are 8. So this tells us now then, cot theta is equal to 4/3 there, and here cot theta is equal to minus 2. So now let's solve these then. Draw a circle. We're solving between 0 and 360. Cot is the same as tan, equal to b in 3/4. So tan is positive here and here. So I've just inverted this fraction and written tan to solve it. So we've got tan is positive here and here. So we draw 2 lines. Mark off the alpha, the associated acute angle to the horizontal, and simply write tan alpha is equal to 3/4. Then do shift tan of 3/4 in degrees mode, which we are. Shift tan, tan of 3/4. 3 divided by 4. 36.86, so it's 36.9 degrees. So our values then, theta will be around to here, which is 36.9 degrees, and the other value of theta is around to here, isn't it? So it's 180 plus 36.9, which is 216.9 degrees. So that's that one done. Now let's draw the other one. This is when tan theta is -1/2, just invert the -2 and invert the cot to write tan. Tan is negative. Tan is positive here and here, so it's negative there and there. Draw two lines again. Mark off alpha, the associated acute angle to the horizontal, and simply write tan alpha and drop the negative if there is one to drop. Shift tan 0.5 or 1/2. So shift tan 0.5 or 1/2, 26.6 degrees. So the other two values of theta we can have are round to here, which is 180 back 26, which is 153.4 degrees, and the other solution is right round to here, which is around 360 back 26.6, which is 333.4 degrees. So there's our four possible solutions for this problem.